A substance that is changed in a chemical reaction. Reactant. A reactant is a starting material in a chemical reaction that undergoes change to form new substances. Imagine you're preparing a meal and you start with a raw potato. Just like the potato changes when you cook it, turning from hard and starchy to soft and edible, a reactant in a chemical reaction is a substance that is transformed into a different substance. In this analogy, the potato is like the reactant because both undergo a change in their structure or composition to become something new and useful, whether it's a cooked dish or a new chemical product. A new substance formed by a chemical reaction product. In science, a product is the end result of a chemical reaction. Imagine you're trying to bake a cake, but you only have flour, eggs, and sugar separately. Just as when you mix these ingredients together and bake them, you end up with a completely new product, a cake. The same thing happens in a chemical reaction. This process is similar to a chemical reaction where individual substances, like flour, eggs, and sugar, combine and undergo a transformation to form a new substance, like a cake, emphasizing how new materials are created from existing ones through specific interactions. The process where substances change into different substances through the breaking of chemical bonds. Chemical reaction. A chemical reaction is when substances mix and transform into new substances. Imagine trying to rearrange a cluttered room into a more functional living space. This is similar to a chemical reaction, where substances transform by breaking and forming new bonds. Just like you move furniture around by disassembling and reassembling it in different ways to create a new setup, chemical reactions involve breaking old chemical bonds and forming new ones to create different substances. Forms hydrogen ions when dissolved in water. Acid. An acid is a substance that releases hydrogen ions H when it dissolves in water, making the solution more acidic. Imagine you're trying to find a comfortable spot at a crowded party, but every time you move, you bump into someone, causing a chain reaction of people having to shift around. When an acid dissolves in water, it's like this party scenario. The acid releases hydrogen ions, which move around and interact with the water molecules, causing a shift in the chemical balance. Just as your move sets off a ripple effect of adjustments among the partygoers, the release of hydrogen ions sets off reactions in the water, changing its chemistry and creating an acidic solution. A compound that changes color when exposed to an acid or a base, like litmus paper. Acid-base indicator. An acid-base indicator is a substance that helps identify whether a solution is acidic or basic by changing color. Imagine you're trying to determine whether a pot of soup is too salty or not salty enough just by tasting it. Just as your taste buds help you detect the saltiness level, an acid-base indicator, like litmus paper, helps detect whether a solution is acidic or basic by changing color. Much like how your taste buds signal the need for more or less salt, the litmus paper changes its hue to signal whether the solution is acidic, turning red, or basic, turning blue, acting as a sensory guide in a chemical context. Forms hydroxide ions when dissolved in water. Base. A base is a substance that can accept hydrogen ions and usually forms hydroxide ions in solution, making the solution less acidic. Imagine you have a puzzle that's been mixed with pieces from another set, making it difficult to find the right pieces to complete your picture. Just as this mix-up creates a challenge in assembling the puzzle, a substance that forms hydroxide ions when dissolved in water changes the environment by mixing new components into it. In this analogy, the hydroxide ions are like the misplaced puzzle pieces that alter the original picture, changing the properties of the water significantly, much like how the wrong pieces change the outcome of your puzzle. The reaction between an acid and a base, it produces a salt and water. Neutralization. Neutralization is when an acid and a base react to cancel each other out, creating water and a salt. Imagine you've got a noisy room filled with both loud rock music and soothing classical music playing at the same time, and it's giving you a headache. Neutralization is like when you find just the right volume of each type of music so that they cancel each other out, resulting in a pleasant, balanced sound that is neither too loud nor too soft. In the same way, when an acid, the loud rock music, and a base, the soothing classical music, react together, they neutralize each other, producing a peaceful mixture of salt and water, much like achieving harmonious silence. The strength of an acid, acidity. Acidity is a measure of how easily an acid donates protons H ions in a solution. Imagine you're trying to open a tightly sealed jar of pickles. Just like the effort you exert to twist and pry open that stubborn lid, the strength of an acid is about how effectively it can release its hydrogen ions. In this analogy, the jar's lid represents the bond holding hydrogen ions within the acid, while your ability to open the jar mirrors the acid's ability to dissociate and release those ions. Thus, a strong acid is like a jar that's easy to open, readily releasing its contents, while a weak acid is like a jar with a stubborn lid, holding onto its contents more tightly. The strength of a base, alkalinity. Alkalinity measures how well a substance can neutralize acids. Imagine trying to find the right pillow for a good night's sleep. Some are too soft, some are too firm, and some are just right. Just like finding the perfect pillow, alkalinity is about finding the right strength or effectiveness of a base in neutralizing acids. In this analogy, the pillow's firmness is like the strength of the base. Too weak a pillow, or base, doesn't provide enough support or neutralization, while the right firmness, or alkalinity, ensures comfort or effective balance in pH. The scale of how basic or acidic a solution is based on hydrogen ion concentration, pH. pH measures how acidic or basic a solution is, with lower values being acidic and higher values being basic. Imagine you're trying to find just the right amount of seasoning to add to a soup to make it taste perfect. Just like how the amount of salt or spice determines whether your soup is bland, perfectly seasoned, or too salty, the pH scale measures how acidic or basic a solution is based on its hydrogen ion concentration. In this analogy, the seasoning is like the hydrogen ions. Too few make the solution basic, like a bland soup. Just the right amount makes it neutral, and too many make it acidic, like an overly salty soup. A change in size, shape, or state, but not in identity. Physical change. In science, a physical change is when the form of matter is altered, but its substance remains the same. Imagine trying to fit all your groceries into a single paper bag, but realizing you need to rearrange them to make everything fit. This is similar to a physical change, where the items, like ice melting or clay being molded, might change form or arrangement, but remain the same at their core. Just as the groceries are still the same groceries no matter how you organize them, a physical change involves altering the size, shape, or state of a substance without changing its identity or composition. A change that produces a new substance. Chemical change. A chemical change happens when substances combine or break apart to form new substances with different properties. Imagine you're baking a cake, and once it's in the oven, there's no way to return it to its original ingredients like flour, eggs, and sugar. This is similar to a chemical change, where substances interact to create a completely new substance, much like how baking transforms your ingredients into a cake. Just as you can't extract raw eggs or flour from a finished cake, a chemical change is irreversible and results in the formation of a new substance, highlighting how the process fundamentally alters the original materials. a combination of substances that keep their individual properties. Mixture. In science, a mixture is when different substances are combined, but each maintains its own properties. Imagine trying to organize a group of friends for a potluck dinner, where each person brings their own dish. Just like your friends each bring a unique dish to the table while maintaining their individual flavors, a mixture is a combination of substances that each retain their own properties. In this analogy, each friend represents a different substance, and their dishes are akin to the parts of a mixture, coming together to form a complete meal while still holding on to their unique tastes and characteristics. A measure of how much solute will dissolve in a solvent. Solubility. Solubility is how easily a substance can dissolve in a liquid to form a solution. Imagine trying to fit all your clothes into a suitcase for a trip. Just like there's a limit to how many clothes you can pack before the suitcase won't zip, solubility is the limit to how much solute can dissolve in a solvent. In this analogy, the clothes represent the solute, the suitcase is the solvent, and the space inside the suitcase is the capacity for solubility. Once the suitcase is full, no more clothes can be packed. Just like no more solute can dissolve once the solvent reaches its solubility limit. A mixture of evenly distributed substances. Solution. In science, a solution is a homogeneous mixture where one substance is completely dissolved in another. Imagine trying to bake a cake, but all the sugar is clumped in one corner of the batter, while the flour is in another. Just like how an uneven cake batter results in a lopsided and unappetizing cake, a mixture of evenly distributed substances ensures a consistent and desirable outcome. In both cases, whether you're baking a cake or creating a scientific mixture, the goal is to achieve uniformity so that every part of the mixture contributes equally to the desired result, ensuring that each bite of cake or each sample of the mixture has the same properties.